Right. Okay, recording has started. Okay. So today we are going to continue our third module, which is machine learning, fuzzy logic. I hope you guys, if anything wrong, just cut me off, okay? I'll stop. All right. So this is what we are going to learn today. I mean, in this module, okay, we are going to go through the overview of fuzzy logic, okay, when did it started, and the fuzzy set versus the crisp set, the fuzzy variables, the fuzzy logic operators, fuzzy control, and case study. Okay, that's what we are going to go through. So fuzzy set and fuzzy logic was introduced by this guy, Lotfi-Zadeh, in 1965, a long time ago. He was a professor at University of California, Berkeley, USA. So fuzzy logic, how it was used is we want to use fuzzy logic in order to make some decision, okay, in order to make decision, okay. Inside the fuzzy logic is a set of mathematical principle for the knowledge representation based on the degrees of membership, okay. That's what is inside fuzzy logic. Okay, basically it's a set of mathematical principles, set of rules. So it started in 1965, and then since then people start using the fuzzy logic algorithm in their work. Okay, started to evolve in the research of computer science field. Okay, until these days, people are still using the fuzzy logic techniques. Okay, so what are the difference between the Boolean? Boolean, as you might know already, Boolean is the 0 and 1. Okay, it's either 0 or 1 value versus fuzzy. What is the difference? Okay, so the conventional, which is the conventional techniques, the Boolean set theory, okay, it's either true or false. Okay, it's rigid, 1 or 0, rigid value. Okay, so for example, a fever. Okay, normal body temperature, how much? What is the normal body temperature? It's 30, 36, right? So whatever that, how can we determine if a person having a strong fever or not? Okay, so for example, for this conventional set theory, okay, it's basically whatever falls in this circle, whatever is greater than 39.3 will fall in this circle, which is strong fever. If it's less than that, it is not categorized as a strong fever. On the other, it's a rigid value. Okay. On the other hand, for fuzzy set theory, okay, the strong fever is like if you have a temperature of your body 39.3, you can still fall out of a strong fever group. Okay. So for example, if you have like 39.3, you can still have a strong fever, and you might also not fall in a group of the strong fever. There are two possibilities. Okay, so that is the difference between the uh, conventional, the Boolean set theory, and the fuzzy set theory. Okay. So basically in fuzzy set theory, we take the value as a more or less rather than either or. Okay, it's like more or less value. Okay, uh, if you have 39.3 body temperature, you can still be not fall into the strong fever group. Meanwhile, for the conventional set theory, if you had 39.3 body temperature, you will fall in the strong fever group, like that. So the differences, okay, for Boolean, set theory, the range of logical value for Boolean is 0 or 1. Okay, it's either 0 or 1. That's it. And for the it's this only two values, okay, for Boolean. And for fuzzy, it is multi-value. Multi-value means it can be whatever number between 0 to 1. Okay? It deals with degree of membership and degree of truth. Okay, this we can talk more on the graph later. Okay, so the fuzzy logic use the continuum of a logical value between 0 and 1. Okay, so if the number fall close to 0, then it can be completely false. If it's close to 1, then it can be completely true. So yeah, so that's the difference between the Boolean and fuzzy. Okay. Introduction to fuzzy logic. So fuzzy logic is a non-linear mapping of an input data to a set of scalar output data. Okay, it's especially for an imprecise concept. For example, age, weight, height, temperature. Okay, to model the imprecise distances, for example, rules such as if it is sunny and warm today, I will drive fast. Okay, this is what we call as the imprecise dependencies. You will the how fast you drive will depends on the weather today. That's what we call as the imprecise dependencies. So fuzzy logic is a way to make use of natural language in logic. Okay, we can all fuzzy logic also use approximate reasoning. Okay, so the crisp or what we call as the traditional set. Okay, the crisp set is the membership of elements in a set is assessed in binary, which is 0 or 1. Okay, an element either belong or does not belong to the set. Okay, the crisp variable represent precise quantities. Okay, for example, we have the value of x equal to 5, y equal to 6. Okay, a proposition is either true, true or false. Okay, for example, if this person fall, if this person young have age younger, no, less than or equal to 30, that means he is young. If his age is between 31 to 50, he is categorized as middle age. And if he is greater than or equal to 51 years old, he can be categorized as old. So there's no any dependencies on that. Okay, it's rigid numbers. Okay. So, on the other hand, for fuzzy set, okay, for fuzzy set theory, it permits the gradual assessment of the membership of the element in a set. Okay, fuzzy set have values in the range of 0 to 1. Okay, so let's see. So if we have two values here, 0.3 and 0.8. Okay, so Hafiz, if it depends on what principle we are going to use. Is it conjunction? Okay, if it's conjunction, and then we will choose maximum value. If it's not, we will choose the minimum value. It depends. Okay, we will touch about that in the next slide. So the crisp versus fuzzy set. Okay, so the crisp set will ask, is the man tall? Okay, draw the line at, let's say, 180 centimeter. The answer is tall men are above 180 and not tall men below this height. That's for crisp. Okay, it's very rigid. You can see here we have the um, degree of membership for the Chris here. Okay, degree of membership for Chris is either only 0 or 1 value only. And then for fuzzy, you can see you have multiple values. Okay, so if the man tall, okay, draw the line. Let's say if the man is 180 centimeters. Okay, 180 centimeters. Here, if you say here, the Chris value is all 1. Okay, this is the value that we navigate with the Chris value. Okay, 1. Okay, whoever that is 180 and above, okay, categorized as tall. Whoever that falls below 180 will be categorized as not tall, which is 0 value. Okay, and then for fuzzy is different. Okay, fuzzy you can see is different kind of graph. Okay, so for example, okay, as can be seen in figure 4.2, David, let's find David. Okay, David have 179 tall, which is just 2 centimeter less than Tom. Tom is 181. Okay, no longer suddenly becomes a not tall or short man as he would in Chris set. If in the Chris set, David will fall in a not tall category here. But in fuzzy set, he will not fall in the, he will be part of the tall categories. Now David and other men are gradually removed from the set of tall men according to the degrees of their height. Okay. All right. So whatever value, for example, whatever value that are close to 1, okay, we consider as true. Okay. So true is 1, 0 is false. Okay, so let's take a look at the graph here. All right, so we have, based on the example earlier, okay, so we draw a graph. Okay, this is the Chris graph. Okay, and this one is the fuzzy graph, the fuzzy graph. Okay, so for Chris graph, okay, we put short, average, and tall. Okay, whoever falls between 170 and 180 categorized as average. Whoever is taller than 180, we categorize as tall. Whoever has height less than 170, categorized as short. Okay, and then for fuzzy, okay, we have different graph here. Okay, we have trapezoid and we have a, triangle graph. So let's say we have this value here. This value. Okay, what is this? 160, 170. Probably here is 168. Okay, let's say 168 cm. Okay, 168 cm, it falls it falls between two categories, okay, which is short and average. Okay, it falls in the middle. Okay, so you, in order to get the degree of membership for that particular person, you can draw the line here, okay, in order to get the value. So let's say the value for this person is 0.3. Okay, 0.3, more or less he will be fall in the short category more than the average categories. Okay, let's see another example. Let's see this example. This example. Okay, so we have 182. 182. 182, he fall between the average and the tall. Okay, so for fuzzy set, okay, fuzzy set, there are like wiggle room, which is for example, here we have wiggle room here, that this particular group of person might fall in this group also. This particular group of person might fall in this group also. It's not rigid like this one, as you like the crease one. Okay, you can see fuzzy here. They have um, cross part here. Okay, some uh, some person might fall into categories. Okay, so that's the difference between the fuzzy and the original crease set. Okay, so for fuzzy linguistic variables. So fuzzy linguistic variables are used to represent the qualities spanning a particular spectrum. Let's say we have age, temperature, time. Okay, this we what we call as the linguistic variable. Okay, linguistic variables. So the temperature, for example, if we have freezing, cool, warm, hot, okay, that what we call as the value of the linguistic variables. Okay, temperature is the linguistic variables, and freezing, cool, warm, hot is the value of the linguistic variables. And how about the membership function? We also have membership function. Okay, we have membership function. So let's say we have a question, what is the temperature? So if the answer it is warm, okay, and then the question again, how warm it is. Okay, so that's what we call as the membership function. Okay, so we will go through the membership function here. So let's say we have the temperature, which is freezing, cool, warm, and hot. Okay, and then the degree of truth of membership here is either 0 to 1. Okay, the degree of truth. So you can see the graph here. Okay, the graph here, the blue line is for freezing. Okay, the turquoise line is for cool, yellow line is for warm, and red line is for hot. Okay, so let's say we have, let's say we ask how cool is 36 degree Fahrenheit. Okay, let's navigate on our graph here. Okay, 36. Okay, 36 degrees. Okay, draw a line. Okay, and then you navigate to the what we call here the degree of truth of membership. So you have two values here. Okay, you have two values 0.3 and 0.7. So the answer will be it is, we convert it into percentage. Okay, it is 30% cool. Okay, because we get the value here. You see the line here, the turquoise line, it belongs to cool, right? The blue, the blue line belongs to the freezing. So it is 30% cool and 70% freezing. Okay. So, how do we use fuzzy membership function in predicate logic? So we have two connectives that you have to remember. One is fuzzy conjunction using these symbols. And then second one is fuzzy disjunction. Okay, this symbol. Don't get confused for the symbols. Okay. So it operates on degrees of membership in fuzzy sets. Okay. Fuzzy disjunction, or if you wanna say in a word, it is or. Or you learn this in, if I'm not mistaken, you learn this in datacom, I guess. Datacom or problem solving. You should learn about, this already, right? Or and okay. So fuzzy disjunction. Okay, fuzzy disjunction. This one with this symbol, and it represent or. So A or B. Okay, we choose the value of max. Okay, we choose the value of max. Okay, A or B equal to C. So the quality of C is the disjunction of the quality A and B. So because it is disjunction, okay, disjunction, we choose the maximum, value. So between these two value, so we should choose the maximum value, which is 0.75. Okay, that's for disjunction. And on the other hand, for conjunction is and. Okay, and okay, A and B. Okay, you should choose the minimum value. Okay, let's say A and A conjunction to B equal to C. So how to read it is the quality C is the conjunction, okay, conjunction of quality A and B. So choose the minimum value. Between these two value, you choose the minimum value. So the answer is C equal to 0.375. Okay. Example for fuzzy conjunction. Okay, calculate A conjunction to B given that A is 0.4 and B is 20. Okay, so first we determine the degrees of membership. Okay, the degrees of membership. Okay, we go zero point 0.4, and then we map to the degrees to the graph. Okay, we got 0.7. And then for B, okay, we have B value is 20, and then map we have 0.9. So we apply the fuzzy and, okay, fuzzy and then A conjunction to B, we should take the minimum value, okay, between A and B, and then minimum between 0.7 and 0.9. So we choose 0.7. So the answer is 0.7. Okay, so fuzzy control. So fuzzy control combines the use of fuzzy linguistic variables with fuzzy logic. Okay, for example, speed control. Okay, how fast am I going to drive today? Okay, it will depend on the weather. Disjunction of conjunctions. Okay, so let's say we have the input here. We have two input here. We have temperature and we have the cloud cover. Okay, so the temperature we have freezing, cool, warm, and hot. The cloud cover we have sunny, partly, and overcast. Okay, the percentage of the cloud cover here. Okay, so let's say we have the speed, which is two variable, slow and fast. Okay, slow, which is below 75 mile per hour, and fast is can be above 25 miles per hour. Okay, so and then we have rules here. Okay, if it's sunny and warm, drive fast. Okay, if it's cloudy and cool, drive slow. Okay, so the driving speed is the combination of the output of these rules. Okay, you have to see the temperature and then the cloud cover in order to determine are you going to drive fast or slow. So let's say we ask how fast will I go if it is 65 degree Fahrenheit and we have the 25% cloud cover. Okay, so we go back to the graph earlier. Okay, so we have the graph. Okay, the temperature. Okay, so we draw the 65. Okay, we navigate where 65 falls. Okay, it falls right here. Okay, and then it falls on two kind of lines. Okay, it falls on the cool lines and also on the yellow line, which is warm line. So you navigate to the value here. Okay, navigate to the value here. So we have for cool we have 0.4 and then for warm we have 0.7 here. 0.7. So that is for the temperature. How about the cloud cover? It says in the questions earlier, it has 25% cloud cover. So 25% cloud cover should fall here. Okay, so it will be cloudy 0.2. Okay, partly cloudy 0.2 and then sunny is 0.8. Okay, so if it's sunny and warm, we drive fast. Okay, that's the rule. Okay, so we have this rule. Okay, sunny cover. Okay, conjunction to warm temperature, we drive fast. Okay, so we have 0.8 conjunction to 0.7. So we choose the minimum value, which is 0.7. So we drive fast. Okay. So if it's cloudy and cool, drive slow. Let's see if it's true or not. Okay. So we do the conjunction comparison 0.2 with 0.4. We choose the minimum value 0.2. So it is slow. Okay. So how that is the fuzzy calculation. So how about the defuzzification? Okay, the defuzzification is we construct the output. Okay, let's say the speed is 20% slow and 70% fast. Okay, find the centroids, which is the location where the membership is 100%. Okay, we want to find where the membership is totally 100%. So we go to the value here. Okay, we go to the value here, okay, we found 25 and 75 mile per hour. Okay, so when we see the value here, we try to get the weighted mean. Okay, what is the weighted mean? Is the value that, for example, that represents in the graph. Okay, so we have 2. 2 is representing 20% here. 7 is the 70%. 25, 25 from this graph. 75 is from this graph. Okay, and 9 is the value of this value. 2 plus 7 equal to 9. Okay, 2 plus 7 equal to 9. So 2 times 25 plus 7 times 25 divide by 9. So you will get the value of 63.8 mile per hour for this specific questions. So as a summary, the fuzzy logic controls allow for the smooth interpolation between the variable centroids with relatively few rules. Okay, this does not work with the traditional Boolean logic lah. So it only works with the fuzzy logic. And also fuzzy logic provide the natural way to model some types of human expertise in the computer program. Okay, so far ada soalan tak? We are going to continue with the next part. Tak ada soalan? Okay, so I will move to the move to part 2. Okay, this is part 1. Mana tadi? Mengantuk kan petang-petang ni? Ada 3 part, tapi saya rasa hari ni kita sempat go through part 1 and part 2 je kot. Okay, dapat tak? Okay, this is part 2. Okay, part 2 ni we will go through all the calculation. Okay, so let's continue. So in this part, you will see, we will go through the fuzzy logic system, type of membership function, the fuzzy logic problem and solution. Okay, so let's take a look at the fuzzy logic calculation. Okay, so a fuzzy logic system can be defined as the nonlinear mapping of an input data set to a scalar output data. Okay, so the fuzzy logic system consists of 4 main parts, which is fuzzifier, rules, inference engines, and defuzzifier. Okay, so when this is the algorithm for fuzzy logic, okay, when you have a problem, okay, first thing first that you have to do is you define the linguistic variables and the terms. Okay, like we went through earlier, the linguistic variables such as temperature. Okay, temperature is the linguistic variables, and the cool, warm, freezing, and hot is the linguistic variable value. Okay, okay, first you define the linguistic variables and the terms, and after that you construct the membership function. The membership function is the value between 0 to 1 lah. And then you construct the rule base. Okay, the rule macam like earlier tadi kita cakap, okay, kalau it's sunny, if it's sunny and partly cloudy, we drive fast. Macam tu. Okay, that's the rule. And then we convert the crisp input data to fuzzy values, okay, using the membership function. And after that, we evaluate the rules in the rule base. And we combine the results of each row and convert the output data to non-fuzzy values, what we call as the defuzzification. Okay, this is the framework of the fuzzy logic algorithm. Okay, so for a crisp set of input data are gathered and convert into fuzzy set using fuzzy linguistic variable, fuzzy linguistic terms, and the membership function. Okay, this step we call it as the fuzzification. Okay, kita convert daripada crisp set of data, input data, into a fuzzy set. That's what we call as the fuzzification. Okay, afterward, an inference is made based on the set of rules, and the resulting fuzzy output is mapped to a crisp output using the membership function in the defuzzification step. So for membership function we use in the fuzzification and the defuzzification. Okay, it's also used to quantify the linguistic term. Okay, there are many types of membership functions such as triangular, trapezoidal, piecewise linear, Gaussian, and also singleton. Okay, this membership function ni like this. This is types of membership function. Okay, so this one is the trapezoid. Okay, this one is Gaussian. This is triangular, and this one is singleton. Okay, for trapezoid, you see here you have a value menaik and then mendata. Okay, and then value menurun. So there will be 4 value for trapezoid: A, B, C, D. And then for triangular, okay, you have A, B, C. And for singleton, it can be A, B, as many values as needed. Okay, and then for Gaussian, you have the middle value here. Okay, that is types of the membership function. Okay, so let's see the difference, okay, of the membership functions between crisp set and the fuzzy set. You can see crisp set is very linear here. Okay, it's very linear. Okay, meanwhile for the fuzzy set, you have the combination of two kind of membership function. This one is trapezoid. Okay, trapezoid, it's connected. Okay, the value before this shouldn't be ignored. Okay, this one. Never ignore the value before and after. This is trapezoid, this is triangular, and this is another trapezoid. Okay, for fuzzy sets. So this is the formula. The triangular membership function formula. Okay, so this formula you can use in order to calculate your membership function value. Okay, so we have A, B, and C to represent the x coordinates of the three vertices in a fuzzy set. Okay, so let's say we have value A, B, and C here. Okay, so if x is the questions. Okay, whatever value that been asked in the question. Let's say the question is about the height. Okay, let's say a person's height, 163. Okay, so this will be the x for this specific questions. Okay, if it's temperature, 36, temperature. Okay, so this will be the x for that particular questions. Okay, so you compare it with the graph given. Okay, so let's say if x is less than or equal to a, okay, automatically you will get the value will be always 0. But if X is between A and B, okay, this is how you calculate the membership function. X minus A over B minus A. Okay, you have to memorize this formula because like during your exam it will not be given. So just try to remember this formula. So X, that is X less than B but greater than A. How about X less than C greater than B? So we use this formula, C minus X over C minus B. And if X is greater or equal to C, then it will always be 0. Okay. This is the A, B, and C value based on the problem given lah. Okay. So that is for triangular. And for trapezoid is different. This is for trapezoid. Okay, trapezoid membership function. So for trapezoid membership function, if X is less than or equal to A, it will be 0. If X is less than or equal to A, less than or equal to B, greater than or equal to A, you use this formula X minus A over B minus A. Okay. If X greater than B less than C, it will be equal to 1. If X greater than C and less than D, you will use this formula, this minus D minus X over D minus C. And if X greater than or equal to D, it will be 0. Okay, this is the value for A, B, C, and D. Okay, don't get confused lah with this value. Okay, A, okay, B and C is graph mendata ni, and then D. Okay. All right. So let's take a look at the problem example. Okay. So you have to develop a fuzzy logic system for intelligent speed control system for a car. The input of your system is the ambient temperature, which taken from the car sensor, and cloud cover data taken weather data server from the weather data server. Okay, so you have temperature and cloud cover data. So your system should suggest the driver what is the appropriate speed based on the input. So maksudnya sekarang ni you have temperature, you have cloud cover, and then you will suggest to the driver how fast or how slow the driver can go based on the temperature and the cloud cover. Okay, so based on the fuzzy logic algorithm here, okay, you define the linguistic variables and the term. Okay, so you have temperature. Okay, temperature, we have freezing, cool, warm, and hot. The cloud cover, we have sunny, partly cloudy, and overcast. And then for the speed, we have slow and fast. Okay, that's the first step. Second step, we construct the membership function. Okay, construct the membership function. Okay, macam yang example in the previous slide lah. Okay, freezing. Okay, freezing ni trapezoid tau. Okay, you don't have to draw this part, but when you are taking the A, B, C value, that will be count. Okay, never forget that part, that missing part. Okay, all right. So we have freezing, cool, warm, and hot. That's for temperature. Okay, and then for the cloud cover, we have sunny, partly cloudy, and overcast. And the output, we are expecting it should be either slow or fast. Okay, now we already have 3 membership function. Okay, 1 for temperature, 1 for cover, and 1 for speed. Okay, third step is we construct the rule base. Okay, we construct the rule base. So if it's sunny and cool, drive fast. If it's sunny and hot, drive fast. If it's cloudy and warm, drive slow. If it's cloudy and warm, drive slow. Okay, you can come with as many rules as you want based on the given questions. Okay, so fourth step is the fuzzification. Okay, fuzzification where we convert the crisp input into the fuzzy values. Okay, let's say we want to answer the question of 81. We have 81 degree Fahrenheit and 20% cloud cover. Okay, let's see. Okay, so 81 Fahrenheit. Okay, kita pergi dekat sini. 81. Okay, 81. And then kita map it touch to graph here. It touch the warm and the hot. Okay, the warm here and hot. Okay, and then for the cloud cover, let's say it has 23% cloud cover. It touch the sunny and the partly cloudy. Okay, so given the value, okay, we have 0.55 for hot and warm is 0.45 and sunny we have 0.85 and cloudy we have 0.1. Okay, so now we have the value. So we evaluate based on the rule that we listed earlier. Okay, the value that we listed earlier. Okay, so we rejected two rules. Okay, we rejected two rules. Okay, the first and the last rules. So there only left two rules here. If it's sunny and hot, we drive fast. If it's cloudy and warm, we drive slow. Okay, so after that, we combine the rules of each rules. Okay, we combine the rules. So if it's sunny and hot, we drive fast. Okay, we drive fast. So you compare the value. Okay, you compare the value 0.85 and 0.55. Okay, the cover, the temperature. Okay, so we choose the minimum value, which is 0.55. So it falls into fast. Okay, based on the speed graph lah. And then for cloudy and warm, drive slow. So let's see. We have 0.1 and 0.45. So we choose the minimum value, which is 0.10. Okay, so the speed will be slow. So the last step, which is the defuzzification. Okay, the defuzzification is when we convert fuzzy data to the non-fuzzy value. Okay, the convert into the non-fuzzy value. So for this part, we want to find the centroid, right? The centroid location where the membership is 100%. Okay, if you remember earlier, the membership 100% should be here, right? Okay, so we have 25% at 25 mph and 75 mph. Okay, so we have the weighted mean here. Okay, 10% and 55%. So we calculate lah. Okay, 10 times 25 plus 55 times 75 over 65. 65 ni 10 plus 55. That's why we got 65 here. So if you calculate, you should get, I think, 63.8, I guess. If you calculate, okay, you will get the speed mile per hour. Okay, any questions? So far, any questions tak? Laju sangat saya pergi hari ini. So far okay? Assume okay lah tu, senyap je. Ke semua dah
Yes,
ngantuk?
madam.
Tak ada question.